Okay, so hello everyone, welcome back to the channel. Today we are solving LeetCode 875, which is Koko Eating Bananas. So this is a problem based on a normal binary search, but here's the interesting part. We are not searching for an element inside an array. We are searching for the answer itself. In other questions we search for like elements, but in this we search for the answer itself. We'll understand that part. But yes, this technique is called binary search and answer, and it's one of the most important interview patterns. Once you understand this problem, many famous interview questions will get easier for you. So okay, so first let's understand the question. So what we are given is we have multiple piles. These are the piles of bananas. One pile has 3 bananas, one pile has 6, one 7, and one 11. Okay, so Coco has several piles, and every hour she chooses exactly one pile and eats like at most k bananas, which is the output basically, like how much bananas she eats in 1 hour or like given a window. So if the pile contains fewer than k bananas, she simply finishes that pile. So like if we are choosing 4 hours per banana, like my bad, 4 bananas per hour. So if the pile contains 3, so she will eat like of course all the bananas in 1 hour. So yes, and in the next hour she will not try to eat the next pile. Then from the second hour she will continue to eat this sixth pile. So okay, so what we have to find is we will be given this r as an integer, and we have to find that if she takes these number of r's, then how much minimum, like the minimum integer, such that she can eat all the bananas within HRs. So yes, you will understand that part. Like okay, so let's come to the whiteboard. Yep. So as we found, like let me write it the example, which was the example on the lead code part. It is 3 6 7 11. Okay, so yep, let's come to the whiteboard. So we have this array 3 6 7 11. So okay, what we are seeing is these are number of piles and number of hours was 8. So number of hours is 8, and in 8 hours we have to find what is the minimum number of bananas she has to eat in each hour, like each hour to complete all the piles. So what we have to do is for the brute approach, we can like try every speed. So basically what she can do is um, like we have the max number of bananas in a pile 11, so we can try every speed. Like she can eat 1 banana per hour, but she can eat 2 bananas in 1 hour, and the max she can eat is 11 bananas per hour, because if she will eat 11 bananas per hour, then this 11 will be completed in 1 hour itself, and total will be 4 hours. So yep, minimum, like the minimum hours that she can complete is 4 hours, but we have to find in 8 hours. So I hope you got the like crux of the question. So what you are thinking, like the simplest solution, the brute approach, what we can think of is like okay, suppose Coco starts eating 1 banana every hour. So check if she can finish. If not, try 2 bananas per hour, and if she cannot like in two also, then try 3 bananas per hour, then try 4 hours, 4 bananas per hour, and whenever we satisfy the condition this 8. So okay, let me try with 2, or like we do not have time for the one part, so let's start with 2. So if she eats 2 bananas per hour, so okay, first she eats, like start eating from the third pile, 3 number pile like this, which has 3 bananas. So in 1 hour she completes, like okay, 1 hour completed, she eats 2. So here left is 1, but she has to eat this 1 banana in another hour. So yep, plus 1 hour. So this pile is over. Now she will move to this pile. Okay, so 6 out, like out of 6 she will eat 2, so 4 will be left, and 4 will be left, but r will be like increased, yes, and to eat these 4, then it will become 2, then it will become 0. So yep, the first for 6 we get like yep, 1 plus 1 plus 1. This one was for 1, and this one for this for completing this one. This one was for going from 4 to 6, and this was 4 from 4 to 2, and the last one would be 4 from 2 to 0. And same with the 7, 3 would be of 6 and extra 1, so yep, this will be 4. And for 11, 5 will be straight because it will be divided, and 1 will be left, so 6. So these are the number of total hours, but yes, these are not satisfying the condition because we need to complete it in 8 hours. So yeah, this will be like total will be 10 plus 1 11 plus 1 12 and plus 3 15. So 15 hours will be taken if we take 2 bananas per hour, but our question requires 8 hours. Now let's try with the correct answer. This is the correct answer. So this is a brute approach. We have to try each speed. So if we try with k is equals to 4, what would be the answer? Let's write it again. If we write it again, 3 6 7 11. Okay, so for eating 3 is less than k, so yes, she can eat in 1 hour itself, so it will be completed in 1 hour. And for 6, 4 bananas will be taken, so 2 will be left, 1 hour for this, then to eating these 2, 1 hour more. And 7, 1 4 like minus 4 will be 3, 1 hour for this, and 1 hour to complete this 3, so plus 1. Okay, so for complete this 11, we're getting 4, right? So 11 minus 4 would be 7. So 7 for to complete it 7, 1. From 7 we will move to 3 plus 1 and will be last plus 1. So yeah, these come out to be 8 hours. We satisfy the conditions. So this is the brute force approach. Like for every speed we'll try, and the max speed would be 11 because there is no mean, like if it is greater than 11 there is no like use of it because it can eat each like in 1 hour, so it's not of use like any use. So these would be, let's say number of piles would be m, we can say 11 is here, and okay sorry, number of piles would be 4, and the highest number of bananas in a pile would be 11, let's say. So let's say m is the number of piles, and we can say n is the number of highest bananas, so the complexity would be m cross n. So yep, it is like a very long time to solve this question, so we will not consider this approach. So this was the brute approach. Now we should move to the optimal part, and it would be like more interesting of course. So let's move to the optimal part. So okay, now we'll move to the optimal approach. The optimal approach is like not a thing that you will get to know like if you are trying to solve it for the first time, because it's a tricky problem. Of course it's a hard problem, it's not an easy one, and if you know the binary search also, then also it's like very hard for you to do it. So yeah, please understand it like in a very focused manner, you will get to it very easily. So yep, so the optimal approach follows binary search as we talked about. So basically it's binary search on answer. You will get to know why this is on answer. So yep, so the highest number of bananas was 11. Okay, right? In the brute force what we did was we tried each possible answer that we could get, like if for like every hour, 1 hour, like 1 banana per hour, 2 banana per hour, 3 hour banana per hour, until 11 we did it. So yeah, this was brute force. So we will do same kind of thing, but we will use binary search, which is much more optimal than the brute force. So let's dry run it and try to understand. Okay, so yep, the search space is still 1 to 11. This is the answer, right? So that's why it is called like the binary search on answer, because we are searching for answers. 1 to 11 can be the answers. So yes, this is why it is called. So okay, what we do in binary search, we have a low pointer, we have a high pointer, and we have a mid pointer. And if we are searching a number, then if it is lesser than the target, then we move right to searches because it's always on a sorted array. And if we need if the mid is greater than the target, then we find it in the left part because it should be less. So yep, this is also in a sorted manner, 1 to 11. So we will use the simple binary search. It is not that much tricky, But yeah, so the iteration 1 would be, mid would be 6, of course. 1 to 11, mid would be 6, so mid would be 6. And if we try to split 6, like the target hours as 8, right? So if we like take 6, if we take pile 3, okay, like 6 means that we are eating 6 bananas per hour. So if we are trying to eat 3, so it will finish it in 1 hour, of course, right? And if we are eating six number of bananas in a pile, it will also take 1 hour because it's 6. And if we are eating 7, then 6 would be completed in 1 hour, but the one that is left, it will take extra 1 hour to eat it, right? So yep, 2 for the 7 pile, and for the 11 pile we will also take 2 hours, right? No doubts. Yep, it is hard, but try to understand it. So total number of hours came out to be, okay, right, so 2 for 7 and 2 for 11 and 3 and like, okay, so total number of hours is 6. So 6 is lesser than the target. Target is, understand it like a normal binary search. It is not hard. Just there are answers instead of numbers, and target is hours, right? So number of hours came out to be 6, so it is lesser than the target, right? In a normal binary search, what we would have done, we would have came to the left part to search for the next possible answer, right? So in this also we will do this only. So if I, okay, now what would it be if the low would be 1 only, but the high would be, because in the right part we will not find our answer, because yes, 6 has came, it is possible answer, but we need minimum. So we will come to the left part, okay. So we'll search the left part. So high will become, which was on 11, it will become mid minus 1, which is in the binary search. So mid minus 1, don't focus on mid minus 1, it will become like 6 we have already searched, no, so left of 6, so basically minus 1, so 5 would be high. And mid would be 1 of 1 and 5 have the mid at, of course, they have the mid at 3, so mid would be 3, right? 5 plus 1 6, divided by 2 3. Okay, so now let me erase this to have a clear understanding. Now Koko is eating 3 bananas per hour. So if she eats this first pile, then it she will take 1 hour, of course. And if we eat the 6 number of bananas, she will take 2 hours, of course. And 7, it will take 3 hours. For 11, it will take, you are just doing what, dividing 11 by 3 and like adding a 1 more hour for the remainder, if there is a remainder, and it is lesser than 3. Yep, right, it is each like 3 plus 3 6 plus 3 9 and plus 2 would be counted at 1 hour. So yeah, 4 hours for this. So 4 plus 3 7 plus 2 9 plus 1 10, so it takes 10 hours. So 10 hours is greater than target, right? So we do not need 10 hours to like eat, we need 8 hours. So we need it is not possible, of course, right? So like if 3 bananas per hour is not possible, so we need a greater value, like less than 6 but greater than 3, right? So what we will do is, we will search in the right part of 3 but left part of 6, so in between 3 and 6. Now we will search between 3 and 6, right? So if we are searching between 3 and 6, so what values will get updated? Let's like think of it. Low will become 4, because of course now we are not needing the left part, because it will come out to be more and more hours, of course. So yep, low would become now 4, and high will like stay 5, because if we go above 5, then we will get less hours, and we do not need less hours. We need more we need less hours than 10, and we need more hours than which came out to be 6, I guess. Yes, for 6 it came out to be 6. So yes, in between we need the value, and the mid would be, for these values, it would be 4, right? So now Koko is eating 4 bananas per hour. So if we try to analyze how many hours it will take, so yeah, 4 is there, so 3 would be done in 1 hour, and 6 would be done in 2 hours, and 7 would be done in again 2 hours, and 11 would be done in 4 into 2 8, and remaining 3 would be okay, so it takes 8 hours. So, yep, we got our answer. So this is like a normally binary search only. If you like go in deep, don't go in deep, but yes, we had an array which was 1 to 11, and we applied simple binary search on it, and the target was 8. So yep, just an extra helper function would be needed, and the helper function is that we are not checking simply the number, we are checking on this array how many hours are being taken. So we will take care of this in the code part, and you will understand like how we are calculating this. We are just calculating the number of pile, like the number of bananas the pile has, and we are dividing it basically by the mid, if you are getting the idea. Because if we are eating 3 bananas per hour, then we are dividing simply like 3 divided by 3 1, and 6 divided by 3 2, so it takes 2 hours, and 7 divided by 2, it's like it's 2 only, but if there is a remainder then we add a 1, like, so it's basically so easy to code. But yes, we will need an extra helper function, and this is only the variation that this binary search has, so we'll keep in mind this. And other than this, it is a simple binary search. So let's move to the code part, and then we will talk about the time complexity. So let's move to the code part first. So okay, we are moving to the code part. We are on the LeetCode, and now we will try to code it very precisely and perfectly. Okay, you will like understand what we are doing and what is the main variation in the binary search. Okay, so what I talked about is we need an helper function. Okay, the helper function is basically when we are traversing this array, this piles array, to get total number of hours. So yeah, we need to calculate it again and again, right? For like for each binary search iteration, we need to calculate it again and again. So we need an helper function. So we can name this as can eat, of course. Like yep, we can do it in camel casing. So we need only to like return true and false for this, because if we are using a binary search, like we only need that okay, if this r is less than or greater than the target. So just we need this that, and we can return it as greater than equal to r and something like that. So okay, what it'll take, if it will take the input as the piles, of course, that is given in the question already, and it will take the r, of course, because it will compare it with the r to the target, and it will take the speed, which would be the mid, while we will be doing the binary search. Okay, so we will start a loop in the piles. We can name it like n, we can say it in the piles, and we will run this loop on the whole array. And this is the like a bit tricky part, not tricky, but we can say the maths part. So in ours, what we need exactly, let me write first, then I will like show you why is this happening. So okay, piles plus speed minus 1 and divide by speed. So okay, you must be thinking it should be only pile by speed, right? You must be thinking that, but okay, let's move to the whiteboard once. Okay, so if you are like able to see, let's say like take example of 11. Okay, let me erase this. Take example of 11. If we are solving for 11 and the speed that we are taking is okay, the answer we can take the 4 as the speed. Okay, so for 11, what we are doing is in R1, okay, 4 are taken, so 11 becomes, we can say 7, 1 hour. Okay, then it becomes 3, another hour, then it becomes 0, another hour. So if we would have, if you say 11 by 4, if we have did, so it would have came like 4 to the 8, and in the remainder it would be 3, right? So yep, we need 3 only, but in this case, like we will use pile plus speed minus 1 by speed. Like pile plus speed would be 11 plus 4 would be 15, and 15 minus 1 would be 14. Okay, and 14 by 3 would be, okay, 14 by 4, because we are taking the speed. So yes, 14 by 4 would be, we can say 4 3 is 12, and we will get the, like if we are taking in the code part, so if we divide 14 divided by 4, if we take this operator, then in the answer we get the 3, the dividend we get. Okay, so yep, we need that 3, right? Because the remainder would not be the answer in all cases, we need the dividend. So yep, that's why we use this formula. Now if we go back to LeetCode, we are here, so that's why we are using this formula. And after this helper function is done, it's not done yet. After this would be done, like what we need true or false for that, right? So if the hours, like the hours that we are like calculating, the for the bananas per hour that it comes, if like it, we will can return the boolean as if it is less than equal to the target, right? So return true, and if it is not, then return false. So yep, this is all we need, because if we want to move right or left in the binary search, of course we need this. Now we will write the main function. Okay, so okay, yep, we will copy this. This was a different function, so this is the answer function that we will be using. We can take this and we would remove this, and we can make this another function. Okay, so this boolean was another function. Now we were moving to the main function. Okay, so now what we would be doing, we will be applying normal binary search, in which low would be 1 and high would be basically, we can say, the max element. Yep, because the max element in all of the piles, we can say piles dot begin and till piles dot end, we need the highest element. That would be our whole binary search array, the sorted array. So yep, we got this, and then we can say int answer. So answer would be, for now we can say high. Yep, we are starting from high. Okay, so how binary search works, while we are not crossing, like the low is not crossing high, till then we will run the loop. And till then what we will do is, first of all we'll calculate mid, which is basically mid of the low and high. So low plus high minus low by 2. Okay, so yep, this is the like mid calculation part. We would be getting the mid part as we got 3, 4 and all those answers. And now we will use our helper function, that if our mid, basically the mid, our mid can, like our mid is, you know, if it is lesser than the hours, then we have to move to the left part of the binary search array, because we need basically the minimum number of bananas, right? So we have to move to the left part, right? So if it is true, then what we'll be doing, answer would be mid, and we would be decrementing the high to mid minus 1, right? Because if it was 6, as we talked on the whiteboard, if it was 6, then we moved to the left 5, so mid minus 1. So yep, high would be mid minus 1. And else, if this condition not satisfied, because if it gives false, it is not it is greater than the target, if we can say, then we will find in the right part, right? So then the low would move, the high will not move. So low would move to the right part, so that the array becomes short, the searching array becomes short, and we can find the answer. And in the last, after running the loop, when the loop would be completed, wherever the answer would be pointing, wherever the answer would be there, we can return the answer. Like at the last it was at 4, so we can return the answer, right? So it was basically the code. But just we use an helper function to calculate the total number of hours, and we compared it to the target hours, and then we use in the simple binary search, the simple binary search architecture. So if we try to run it, it should run correctly. We can check it. And talking about the time complexity would be if we are seeing like the binary search has, okay, so it has okay, you know we did not define the variable hours, so now it should work, right? Hours equals to 0. Yep. So if we talk about the time complexity, we can see binary search has a time complexity of log n because it divides the array every time in logarithm parts, like divide by 2, divide by 2, divide by 2. So this is basically of binary search, and we are traversing the piles array every time. So yup, this is also time complexity part only. So the time complexity would be the number of piles into log n, we can say. So this would be the time complexity. So yep, n into log max pile, like log of max pile, it would be the answer, because we are binary search, we are taking on the max pile array, and n is the size, n is the number of piles in the question. Okay, so yep, this was all for today. If you like the video, you can like subscribe to my channel. And this was a hard question, so if you are not able to do it, then don't consider yourself weak. This was a hard question, and let me just fix this thing now. Just a minute. Okay, so this was just a typo error of this n. I thought I'd take care the piles part, so yes, it's not a problem, big deal. We just can help a function, we run the binary search. This is the basic idea of the question. If you are explaining it to an interviewer, then you take from the start. First explain the brute force that we can try for each number of bananas per hour, and then you can move to this approach, that is the binary search approach, by using an helper function. This is much more optimal, and its time complexity is much more smaller than to the brute force approach. So that was all for today. Thank you so much for watching, and thank you so much.